At first glance, mathematics seems like the purest form of truth, rigid, logical, and precise. But in 1901, British philosopher and logician Bertrand Russell exposed a hidden crack in that perfection with what is now famously known as Russell's paradox. A simple question, couched in the language of sets, became a wrecking ball that demolished the foundations of early set theory and forced mathematicians to rebuild their entire logical framework. Here's how it works. In naive set theory before formal restrictions were applied, it's perfectly reasonable to imagine a set of things that don't contain themselves. For instance, the set of all cats doesn't contain itself because it's not a cat. So what about the set of all sets that do not contain themselves? Let's call this set R. Now the trouble begins. Does R contain itself? If it does, then by definition it shouldn't, because it only includes sets that don't contain themselves. But if it doesn't contain itself, then by its very definition it must include itself. So either way, we arrive at a contradiction. That's the paradox. Russell's discovery sent shockwaves through the mathematical world. At the time, mathematicians like Gottlob Frege were working to place all of mathematics on a logical foundation, and Russell's letter to Frege about the paradox destroyed the core of his life's work overnight. In Frege's own words, arithmetic totters. This paradox revealed a fundamental problem with naive set theory. It allowed sets to be defined too freely, leading to contradictions. The fallout was significant. In response, new frameworks were built, such as Zermelo-Fraenkel set theory, ZF, with its axiom of regularity, and type theory, which imposed strict rules to avoid self-referential sets. Russell's paradox didn't just change math, it forced a philosophical reevaluation of the very nature of truth, reference, and structure. It exposed the fragility of logic when pushed to its edges and remains one of the most important discoveries in the history of mathematics and philosophy. Today, the paradox serves as both a cautionary tale and a cornerstone in the development of modern logic. It's a reminder that even in the world of mathematics, where everything is supposed to add up, paradoxes can emerge from the simplest assumptions. In challenging the very notion of what a set is, Russell forever altered how we understand logic, truth, and mathematical certainty.